Why didn't Jupiter become a second sun? The answer lies in its mass. While enormous, it still falls short of the threshold needed to ignite nuclear fusion. Without this crucial spark, Jupiter cannot burn like a star. Instead, it quietly radiates the residual heat left over from its formation. But that raises deeper questions. Where does this internal heat originate, and what drives the chaotic, untamed atmosphere that rages across its surface? To uncover these mysteries, we must journey to Jupiter, diving beneath its colorful skin to explore the hidden forces at play. As you approach this gas giant, its surface fractures before your eyes like a shattered mirror, revealing stunning patterns of cloud bands, alternating belts of rich brown and pearly white that stretch and twist around the equator. These striking bands are not mere decoration. They are the living signatures of powerful jet streams carving through the upper atmosphere. These high-speed winds spiral around the planet like colossal serpents, their energy organizing the atmosphere into distinct zones. Jupiter's entire atmosphere is sculpted by alternating jets of air flowing eastward and westward, racing from the equator to the poles. The further you go, the more intense the winds become. In the bright zones, ammonia clouds rise from the depths, reflecting sunlight and glowing in shades of white and gold. In contrast, the darker belts expose deeper atmospheric layers, stained rust red and amber by sulfur compounds and ammonia-based chemicals. Each band flows in the opposite direction of its neighbors, forming a giant, dynamic painting shaped by unimaginable gales. The wind speeds on Jupiter can soar to hundreds of kilometers per hour, far surpassing the fiercest hurricanes on Earth. In the upper layers, jet streams can scream along at over 650 kilometers per hour. Driven by the planet's rapid rotation, the atmosphere is stretched into high-speed bands, divided into clear zones separated by bright and dark cloud patterns. These jet streams are flanked by turbulent transition zones, areas where air masses of different speeds and directions collide, twisting into spirals, waves, and chaotic eddies. Beneath these surface phenomena lies the true engine of Jupiter's fury. The planet's internal heat continuously powers deep atmospheric convection. Warm gases rise, cool gases sink, and this endless cycle breathes energy into the jet streams, sustaining the never-ending aerial ballet. Between the jet streams, you can observe striking cloud formations, gleaming white ammonia clouds forming where gases ascend, and clearer regions where the air sinks, exposing deeper, darker layers. Viewed from above, Jupiter resembles a living, swirling slab of marble. Color pulses through it like blood through veins. Amid this turbulence lies one of the most famous features in our solar system, the Great Red Spot. This massive reddish-orange oval storm has roared in Jupiter's southern hemisphere for centuries. It is so vast it could swallow Earth whole. Technically, the Great Red Spot is an anticyclone, a high-pressure system spinning counterclockwise, towering above the surrounding cloud tops. Up close, you would see its dense, swirling clouds forming an oval shape, their colors reminiscent of weathered brick. A red haze hangs above, cloaking the storm in an eerie glow. Scientists still don't know exactly what gives it that color, perhaps complex organic molecules or mysterious materials from deep within the planet. Inside the vortex, clouds spiral like a colossal eye, with winds at the periphery reaching speeds of 430 kilometers per hour. These winds sculpt the clouds into surreal, dreamlike forms. Since it was first observed over 150 years ago, the Great Red Spot has fascinated scientists. White ammonia clouds tumble along its edges, sometimes getting pulled into the vortex. Smaller storms occasionally approach. Some are repelled, others consumed. The Great Red Spot doesn't just dominate its own patch of sky, it also influences weather patterns in distant regions of the planet. Yet, recent observations reveal that this once majestic storm is shrinking. Its diameter is now half of what it was at its peak. Still, it remains the largest storm in the solar system, completing a full rotation every 6 Earth days. The storm's core is slightly calmer than its outer edges, and above it floats a mysterious red haze that separates it from the surrounding bright clouds. Occasionally, lightning flares within, briefly illuminating the towering cloud walls with flashes of ghostly brilliance. NASA's Juno spacecraft has shown that the storm's depth may not be as immense as once thought, but it still rises tens of kilometers above the surrounding clouds, like a gaseous mountain standing firm amid a stormy ocean. And the Great Red Spot is not alone. Jupiter's entire atmosphere teems with smaller storms and vortices. If you follow the wind bands, you'll find chains of white ovals, tiny anticyclones spinning in the same counterclockwise direction. Though far smaller than the Great Red Spot, some of these mini-storms persist for decades. Others vanish within days. In 2000, 3 such white ovals merged to form a larger storm known as Oval BA, which later turned red and earned the nickname Red Jr. It's about half the size of the Great Red Spot. Between these storms, the relentless jet streams stretch and twist the clouds into narrow vortex bands. At the boundaries between light and dark regions, ripples and waves form, some even displaying Kelvin-Helmholtz instabilities, those mesmerizing waves that occur when airflows of different speeds slide past each other. This is Jupiter, a world sculpted by storms, bursting with heat from within, swirling and boiling in a silent, majestic fury. Its atmosphere dances in patterns both beautiful and violent, an eternal stormscape shaped by forces still not fully understood. Sometimes, if you look closely at Jupiter's turbulent atmosphere, you can spot dark, small eddy clouds drifting slowly along the jet streams. In contrast, bright, popcorn-like cloud clusters mark the presence of powerful convective storms rising rapidly. Without a solid surface to interfere, these storms can plunge deep into the atmosphere, surviving longer and raging more fiercely than any on Earth. Scanning along Jupiter's vast curvature reveals a grand spectacle of atmospheric motion, from tiny whirlpools only a few hundred kilometers wide to massive chaotic regions where multiple vortices collide in turbulent clashes. It is a feast of flowing energy displayed across the face of the planet. Especially behind the Great Red Spot, air currents become heavily disturbed, creating a chaotic region teeming with swirling clouds and pale storm cells. This storm nursery is where new systems are born. Yet, beneath the apparent disorder lies a deeper layer of atmospheric order. Every storm remains tightly locked into its own latitude band, anchored by the planet's powerful jet streams. None of them can escape their designated corridors. If you soar over Jupiter's poles, the sight will leave you breathless. At the North Pole, 8 colossal polar cyclones encircle a central vortex in a near-perfect octagonal formation. Each cyclone spans between 1,500 and 2,800 kilometers in diameter. Despite being closely packed, they spin independently, each maintaining its own graceful spiral as if an invisible hand orchestrates their balance. All of them rotate counterclockwise, their spiral arms intertwining with perfect geometry. Nature's version of a superpowered symphony of motion. A similar phenomenon unfolds at the South Pole. Initially composed of 5 cyclones surrounding a central one, a 6th eventually joined to form a perfect hexagonal pattern. These polar storm arrays have persisted for years with remarkable stability, hinting at complex underlying physics. Perhaps an elegant balance of fluid dynamics among the vortices, or the polar jet streams providing structural support for the entire system. Just as you're marveling at this polar geometry, Jupiter reveals yet another card: lightning. A brilliant bolt flashes across the polar night, illuminating the cloud tops in a vivid glow. But this is no ordinary lightning. It's an eruption of immense energy, a cosmic storm unmatched in intensity. As early as 1979, the Voyager spacecraft captured fleeting, dazzling flashes in Jupiter's upper atmosphere, our first glimpse into the electrical heart of this gas giant. Initially, scientists believed that Jupiter's lightning occurred only deep within water-rich cloud layers, where conditions mimic Earth's storm systems. But with the Juno mission's close observations, a startling truth emerged. Lightning can also occur high in the atmosphere, in regions where temperatures plunge to 88 degrees Celsius, well below the freezing point of water. Under such conditions, water should be frozen solid. Yet ammonia plays the role of an antifreeze, keeping water in a strange, partially liquid state. In the heart of violent storms, hailstones are hurled up to altitudes exceeding 24 kilometers, entering zones saturated with ammonia vapor. There, the hail begins to melt and blend with ammonia, creating a muddy, icy slurry. These bizarre mushball hailstones rub against each other with tremendous friction, building up electrical charge until shallow lightning bursts forth. These lightning flashes, igniting in clouds laden with ammonia and hail, set off a brief but powerful symphony of electric light, casting eerie blue and golden glows across the sky. The Juno probe has captured these spectacular moments in stunning images. Though each flash lasts only a few milliseconds, their intensity rivals Earth's most violent lightning strikes. Deeper within Jupiter's atmosphere, some 48 to 64 kilometers beneath the cloud tops, traditional thunderstorms still rage. In these deeper layers, water exists simultaneously as liquid, vapor, and ice. This mix, under high pressures and temperatures, drives dramatic charge separation and explosive lightning bursts, whose energy exceeds Earth's by several magnitudes. Juno has detected tens of thousands of such strikes and recorded the sharp whistling radio emissions they produce, echoing through Jupiter's vast magnetic field into space. Even more exciting is how these shallow lightning bursts have helped solve a long-standing scientific mystery: why ammonia appears mysteriously depleted in Jupiter's upper atmosphere. As it turns out, those mushball hailstones formed from ammonia and water are silently dragging ammonia down into the depths, hiding it from detection. With each lightning strike, the sky flashes once more, illuminating towering convective cloud structures, clouds driven upward by the planet's internal heat, sometimes soaring over 30 kilometers high. Brief bursts of lightning outline these titanic structures, like the cosmic hammer of Thor shaping the atmosphere of a storm-breathing world. Yet if the storms and clouds paint a wild and majestic portrait of Jupiter's atmosphere, then its auroras are the crown jewels on the king of planets. At both poles, dazzling auroral rings blaze with breathtaking energy, glowing in deep blues and violets like gemstones in the night sky. Unlike Earth's auroras, which flare briefly during solar storms, Jupiter's auroras are nearly constant, burning with an intensity hundreds of times greater than those seen on Earth. They wrap the polar skies in an unending cloak of electric fire. These auroras are driven not only by solar wind, but also by Jupiter's immense magnetic field, which is 16 to 54 times stronger than Earth's. This magnetic field, generated deep within Jupiter's metallic hydrogen core, traps and guides high-energy particles toward the poles. When these particles strike the upper atmosphere, they excite atoms and molecules, releasing ultraviolet and infrared light in giant glowing rings. Images reveal a stunning sight. At the North Pole, an electric blue spiral twists and dances, following invisible lines of magnetic force. But Jupiter doesn't perform this light show alone. Its moons play a crucial role, especially Io, the volcanically active moon that constantly spews sulfur and oxygen ions into space. These particles feed Jupiter's magnetic field, fueling its auroras even further. As Jupiter rotates, the charged particles are flung toward the poles, igniting the polar light displays. Io's signature can be seen within the auroral ring, a bright flickering mark that glows like a torch, illuminating the magnetic bond between the moon and its mighty parent. Europa and Ganymede, too, leave their imprints, joining the celestial choreography. Sometimes, when solar activity intensifies and a barrage of high-energy particles slams into Jupiter, the auroras explode in brightness, rising thousands of kilometers above the cloud tops, towering far beyond anything Earth has ever witnessed. Even if you were hovering above Jupiter, you wouldn't be able to see these breathtaking wonders with your own eyes. That's because much of their radiant beauty is emitted in ultraviolet and X-ray wavelengths, far beyond the range of human vision. Jupiter's auroras aren't just visual marvels. They are electromagnetic symphonies, dancing with raw power across the poles of the solar system's mightiest planet. Let's now pull back, expanding our view from Jupiter's blazing auroras and churning cloudscapes to reveal another hidden marvel: Jupiter's rings. Yes, Jupiter has rings too, but unlike Saturn's brilliant, iconic rings, Jupiter's are faint, wispy, almost invisible. They're like cobwebs suspended in the void, and remained undiscovered until 1979. These rings lack the grandeur of Saturn's, composed instead of incredibly thin, diffuse material, nearly transparent and only visible when backlit by the sun. In such rare glimpses, a narrow glowing band called the main ring can be seen encircling Jupiter's equator, flanked by gossamer ghost-like halo rings further out. These ethereal structures wouldn't exist without the quiet contributions of Jupiter's inner moons, particularly Amalthea and Adrastea. These small satellites, barely visible as dim specks of light, are constantly bombarded by micrometeoroids. The impacts eject fine dust into orbit, which gradually accumulates to form Jupiter's faint, dusty rings. The primary source of the main ring is Adrastea, a tiny moon only about 19 kilometers in diameter. Slightly farther out, moons like Medes and Amalthea supply additional dust for Jupiter's outer gossamer rings. Up close, the ring particles are unimaginably small, micron-sized silicate fragments, dark in color and nearly non-reflective. In visible light, they vanish into the backdrop of space, revealing themselves only under infrared imaging or rare, perfectly aligned backlit conditions. So what kind of world is Jupiter really? When you piece together the churning atmosphere, the torrents of internal heat, the birth of lightning in its colossal storms, the auroras that ignite its polar skies, the hidden dust rings, and the multitude of moons that accompany it through space, Jupiter becomes far more than just a planet. It is a dynamic system, a cosmic symphony in perpetual motion. Jupiter is a king not only in scale but in spirit, a celestial monarch burning with endless transformation. There is no need to summarize him. No description, however vivid, could truly capture his essence. For since the dawn of his birth, Jupiter has carried the primal scars of a chaotic universe. And to this day, buried in the vastness of the starry sea, he continues to roar with thunder and blaze with light, telling stories of the cosmos that are still being written.